statistics cumulative frequency graph or OGIV curve or cumulative frequency polygon. 5 marks Introduction. Francis Galton coined the term OGIV to describe the shape of the normal distribution function as it has a form similar to the S-shaped Gothic ogival arch. OGIV means diagonal arch. Cumulative frequency of any class is the sum of the frequency of all classes preceding that class and its own frequency, or it can be said as the added up frequencies. The cumulative frequency is plotted on the y-axis against the data. The graph represents the data of a cumulative frequency distribution. An OGIV, sometimes called a cumulative frequency polygon, is a type of frequency polygon that shows cumulative frequencies. In other words, the cumulative percent are added on the graph from left to right. An OGIV graph plots cumulative frequency on the y-axis and class boundaries along the x-axis. Definition: an OGIV is a line plot of the cumulative frequency distribution against values of the random variable. An OGIV is a way to graph information showing cumulative frequencies. Graph that represents the cumulative frequencies of the classes in the frequency distribution is called OGIV curve. Cumulative frequency is a graph plotting cumulative frequencies on the y-axis and class scores on the x-axis. The OGIV is a graph that represents the cumulative frequencies of the classes in the frequency distribution. An OGIV is the curve which is constructed by plotting the cumulative frequencies in the form of smooth curve. From such curves one come to know about the frequencies corresponding to a certain lower or upper limits in the distribution of the data. Features: the vertical scale represents cumulative frequencies, the horizontal scale represents upper class or interval boundaries. OGIVs always start at the left with cumulative frequency of 0 at the lower class boundary of the first class. The difference between frequency curve and an OGIV is that in the later, we plot the cumulative frequency on the y-axis rather than plotting the individual frequencies. The OGIV should end on the right with the cumulative frequency equal to the sample size at the upper class boundary of the last class. Uses graph rather than bar graph. Uses class boundaries on x-axis. Uses cumulative frequencies rather than individual class frequencies. Methods / ways / types of constructing an OGIV. There are 2 types of OGIVs. 1. Less than method. 2. More than method. Less than method, less than OGIV. We go on adding frequency beginning from lower limits, we get an upward rising curve called less than OGIV. More than method, more than OGIV. We go on decreasing frequencies beginning from upper limits, we get a declining curve called more than OGIV. Drawing an OGIV curve. For drawing an OGIV, an ordinary frequency distribution table is converted into cumulative frequency table. The cumulative frequencies are then plotted corresponding to the upper limits of the classes. The points corresponding to cumulative frequency at each upper limit of the class are joined by a freehand curve. The diagram made is called OGIV, or find the cumulative frequency for each class. Draw the x and y axis. Label the x-axis with the class boundaries. Label the y-axis with an appropriate frequency. Plot the cumulative frequency at each upper class boundary starting with the first upper class boundary. Connect adjacent points with line segments. Extend the graph of the first lower class boundary on the x-axis. Uses of OGIV. Middle dot. The cumulative frequency graphs are used to find the median of the given set of data. The point in which both the curve intersects, corresponding to the x-axis, give the median value. Middle dot. OGIV curves are used in computing the percentiles of the dataset values. Middle dot. It allows one to quickly estimate the number of observations that are less than or equal to particular value. What is OGIV and its uses? An OGIV, also known as a cumulative histogram, is a graph that is used to determine the number of data points that are equal to or below a certain value in the dataset. Middle dot. One can use OGIVs to determine the median and percentiles of a dataset. It is useful in knowing running total of frequencies, as it tells the total number of data items at different stages in a dataset. T advantages: it enables median, quartiles, etc. to be studied from a graph. Very informative when examining how values are changing within the dataset. Disadvantages: difficult to compare the frequencies between each data group. It requires high bandwidth. It is difficult to compare different data sets.